Welcome to the Advanced Water Heating Initiative Commercial Working Group call. Today is December 12th, 2024. Great to have you with us. I'm Joe Wachunas with New Buildings Institute. I'm here filling in for our working group lead, Kashmira engineer, who will probably be joining us today, but is a little under the weather, as so many of us are this time of year. So I'll be pinch hitting, but we'll have some great presentations. We'll get into that in just a second. I'll read our antitrust compliance statement pretty quickly. The Advanced Water Heating Initiative is a member-supported collaborative of professionals from across the U.S. This diverse membership includes numerous competitors, and care must be taken to scrupulously abide by federal and state antitrust laws. Members should remember that antitrust compliance is important at all times. At this and other AWHI meetings, participants should not discuss competitive pricing, profitability, allocating markets or customers, or promotion of a particular product or accessory. All righty. Well, and then a quick thanks, as always, to our sponsors of the Advanced Water Heating Initiative, the Department of Energy, NYSERDA, ComEd, Bonneville, Power Administration, Southern California Edison, McKnight Foundation, and NEA all make it possible for us to do this convening work, this crucial work to move the industry forward together in a balanced and brand neutral way. So if you'd like to be an AWHI sponsor, we'll put a link in the chat, but thanks so much to all our sponsors for allowing us to do this initiative. All right, well, let's get to our call agenda today. We'll get to some, we'll do some introductions and also a couple announcements. And then we'll turn it over to my colleague Vidhisha and Doug Lindsey from EPRI, who will be talking to us about these, just some different form factors that could work for in-unit multifamily water heater replacements. They'll take us to around the 12:30 mark Pacific. Then we'll hear from a manufacturer spotlight, Solaray, thermal water heaters and how they could potentially be paired with heat pumps. So excited to hear that from Amir Habibi. And then finally, last but certainly not least, we're going to be hearing from Todd Amundsen from BPA, who's going to talk to us about this case study of a commercial heat pump water heater at Cowlitz YMCA. So excited, got a good variety of topics today, but as we usually do, we'd like to welcome new folks to the commercial AWHI working group. If you are here for the first time, or if you have big news to share, I guess we'll let returning folks who might have big news to share come on mic as well. But so new folks or folks with news to share, please come on mic and tell us your name and organization.
Hey, good afternoon, everybody. My name is Jimmy Galvan. I'm with the City of Anaheim Public Utilities, overseeing the commercial and industrial programs here within the City of Anaheim. Thank you.
Oh, great. Welcome. Great to have you on. Fantastic.
Thank you, sir. Thank you, Joseph.
Thanks for coming on. Yeah, and I think, Abby, you did a great job. I love the raising the hand, makes it easy as well. So I'll turn it over to Abby Dakin at Energy Star.
Yeah. Abigail Dakin, EPA Energy Star, and I just wanted to make sure everyone saw that the the central heat pump water heater test method final draft came out. We look forward to your comments. By December 19th, I'm sorry to give you so little time. We're trying to move this forward. And we hope to finalize the test method and also release to draft one of the specification early in the new year.
Fantastic. Great. We'll be actually talking about that shortly. So thanks so much. Appreciate that. Thanks. Go ahead, Josh.
Hi, it's Josh Witzbaugh from PNNL. I've been to a few of these meetings before for the commercial working group, but PNNL has some new work from DOE to look into building developer decisions as to why they go with in-unit versus centralized heat pump water heating equipment, and also building owners who retrofit their buildings as to why they choose one or the other, particularly if they're switching from in-unit to, going mainly from centralized to in-unit would be probably the main retrofit. But if anyone has some feedback on the decision-making and processes, or can get me in touch with some building owners or building developers who've done such projects, that would be fantastic. And I'll put my email into the chat. So thank you all.
Great. Thanks, Josh. Appreciate it. Yeah, really yeah, really important information, that decision between in-unit and central. Great. Thanks, Ryan Hamilton from CE. Go ahead.
Hey, Joe, thanks. Good to see everybody. Just a quick reminder that CE has also launched our qualified products list for commercial heat pump water heaters, and that includes both gas and electric models. So I'd like to encourage all of the OEMs on the call here to look into that and get your products submitted so that we can get them represented on our QPL, and our members that span across the United States and Canada can start including your products in their incentive programs. Thank you.
Fantastic. Thanks, Ron. Appreciate that. Great. See some other folks raising hands. We're looking for either folks with announcements or new folks to the group. Yes, go ahead. And I just lost your name. Excuse me. It's Sadi.
Yeah, thank you so much. My name is Saide. I'm from Ministry of Energy and Climate Solutions, Government of BC. We're working about regulations of new equipments to accelerate and promote residential buildings to bring heat pumps and new technologies to tackle GHG emissions and improve the efficiency. And I'm new in the team. Would be glad to hear more about the technologies and all the stuff around the topic.
Fantastic. Wow, exciting stuff. Yeah, great to have our neighbors north of the border. We have lots of great Canadian participation. So great to have you on. Thanks for being on. And yeah, love to stay in touch. Thank you. Nicholas, go ahead.
Yeah, Nick Day. I'm working for Small Plant Supply as an R&D manager, and we build central water heat pump systems. And we're currently working on a thermal energy storage system to match up with CO2-based heat pumps. And if anybody can help me find the thermal energy storage section at HPWH or ASHRAE, I'd really appreciate it. Want to, understand the logistical concerns and regulatory environment moving forward, and I'd like to get involved that way. Thanks.
Awesome. Thanks, Nick. Yeah, please put your email in the chat so folks can reach out. It'd be great. Thanks. Go ahead, Bob.
Yeah, with Bob Ellis with H-Tech manufacturing of the Medusa PCM heat pump thermal storage unit.
Fantastic. Welcome. Exciting. Great. Well, let's keep moving. Thank you, everyone. If we missed anyone, please put your name and organization in the chat. Even folks returning to the group, feel free to do so. Great. Of course, one of the main scopes of this group is to foster connection amongst our community. So great. Thanks for those updates. Thanks for the new folks on the group. John Heller, are you on the call? I think you were going to take the next slide or two.
I am on the call.
Great.
So this is just to let people know that there's been some progress made at the DOE to develop progress in pointing the way towards development of a test standard for commercial heat pump water heaters that's going to work a little bit better for moving the industry in a positive direction. So the current standard that has been used has been a single test point that was really non-representative conditions: 80-degree entering air temperature, 70-degree entering water, 120-degree leaving water. Not really representative of a heat pump out there working in a climate throughout the year. And that's going to be shifted to use multiple test points that are a little more aligned with the way the advanced water heating specification is developing performance map over a wide range of conditions that are more representative of real climates. The current standard has no defrost impact taken into consideration, and the proposed test standard will have either tested numbers or there'll be an assumed D-rate if there's no test done by the manufacturer. There's also going to be added a way for the manufacturers to indicate what the minimum temperature that it's tested at, so that below that temperature it'll be assumed to be any water heat be assumed to be provided by a backup system. And then there's a new efficiency rating, which I hadn't heard about this before, but it's just being proposed, called a WEIR, which will use average national outdoor air temperature bins with that tested performance map and assumed defrost derate to come up with an average equipment only efficiency rating for the heat pump. So progress. We still see this, the advanced water heating spec and the qualified products list is based around a full system efficiency, and this DOE proposal is still just looking at the heat pump itself. And we know from experience that the performance in the field is strongly driven by the design of the system. So the system effects are pretty big, but this is at least a step in the right direction for the DOE.
Fantastic. Thanks, John. And then stay on the line if you don't mind. Helen Townsend is the project manager for scaling up, but gave us a couple of the updates. Anything that you want to comment on? Otherwise, I can speak to this slide. She's not able to join us today.
Okay, yeah. So the scaling up project is one of the DOE demonstration projects for commercial heat pump water heaters that's launched. A lot of the first chunk of work has been around market research, figuring out what training needs there are out in the industry, and solidifying some of the 6 project demonstration sites that we'll be monitoring and developing training materials and case study materials around. We have 3 West Coast demonstration sites recruited. We're still looking for solidification of demonstration sites in New York and in the Midwest. So if anybody who are looking for multifamily buildings, affordable multifamily ideally, and we need systems that could be installed by the end of 2025 or the end of Q3 2025.
Well, great. I think there have been some conversations in Minnesota, so hopefully that Midwest site will come to pass. Thanks, John. Great. Noah Gabriel, my colleague, is project managing the MAGIC, the sister project to scaling up, and wanted to provide some updates on the MAGIC project.
Yeah, sure thing. Thanks, Joe. So quick updates here. The pictures you see are from Splash Blocks, so thanks very much to Ecotope for taking those. Splash Blocks is the first installed project in Portland, Oregon. So first of 6 for the MAGIC project. And unlike scaling up, where the technologies are kind of field proven already and kind of ready to scale up, the MAGIC technologies are new to the market. So new heat pump systems, new heat pumps. So all exciting stuff. So we have this 1 site installed, and then we have 2 to 3 committed. So this is in Pacific Northwest, and then we have a couple of California sites and a very likely go site in Chicago as well to look at cold climate. And then in 2025, we're hoping to recruit 2 sites in the East Coast. So ideally New York City market or nearby. So yeah, that's the most recent updates in 2025, kind of hoping to finish most of the installs and get MNB equipment on there, start collecting some real data on system performance.
Thanks, Noah. A quick follow-up question. Did you say which manufacturer is this?
Yeah, I have. I didn't. So for Splash Blocks, I believe it is Nile. And it shows on the picture here. It is Nile, and then we have 5 other manufacturers who are participating as new technology testing.
This one is the Nile E series, so it's their newest series of heat pump.
Fantastic. Great. All right. Well, thanks to you both. Really appreciate that update. And a couple quick other announcements, and we'll get to our programming for today. So just a quick shout out. Next Wednesday at 10 a.m. Pacific, we have our big quarterly all stakeholder meeting. This is our big tent meeting. We invite all our working groups together, talk about big things. This quarter, we're going to be talking about how to market heat pump water heaters. We're going to have Energy Star on, as well as the Building Decarbonization Coalition, which runs the Switches On program. And then second half of the meeting, we'll be talking about the state of the market, the heat pump water heater state of the market. We're finalizing an annual report on how things are looking for heat pump water heaters. A sneak peek, they're looking pretty good. And then also what remaining challenges and barriers need to be overcome, and having a product landscape, just a little overview of all the different commercial and residential heat pump water heaters on the product or on the market in the US. So this report will be coming out shortly after our all stakeholder meeting, which will be next week, but you'll be getting a sneak peek of that report one more time on this. If you want to get the calendar invite, these are live links. We'll send the slides out as well. Great. Well, thanks, everyone. Thanks for the announcements. We're a little bit behind schedule, but had put some room in our meeting agenda to accommodate that. So for this, we're going to turn our attention over to heat pump water heaters in multifamily, and specifically the in-unit heat pump water heaters. You heard Josh Butzba talking about whether there's a central heat pump water heater in-unit. This working group usually focuses on the central heat pump water heater systems for multifamily buildings, but they're split about 50-50, whether apartments have them in unit or rely on the central ones. And so we're going to be hearing from two people. First, my colleague Vidhisha Moopnar, who has been doing some research as part of the DOE heat pump partnership to look into what products might be good for these in-unit multifamily replacements where there's not a lot of space and maybe not a lot of airspace. So looking at some different options there. And then we'll hear from Doug Lindsey from EPRI, who will be talking about some of their research on this same topic. Vidhisha pre-recorded her video because we just had an in-person working group meeting, and she was flying back, and she's here on the call, but was possibly going to miss it. So we're just going to hear her recorded presentation here, but she's here for questions as well. And let me share here. Let me know if this is working for folks. Oh, sorry, I'm going to have to share audio. Excuse me. Okay, here we go.
Good afternoon, everyone. I hope you all are doing well and wishing you all a very happy Thursday. My name is Vidhisha. I'm a project analyst with the Building Innovations team. And today I'm going to be having a conversation with you all about heat pump water heater emerging technologies, or as we would call it, form factor solutions that could be well defined and meaningful in a multifamily building unit. When we talk about multifamily buildings, I was just curious, like, what would be the percentage share across US in different states? And I'm not surprised that California leads the highest number of apartment stock, followed by Texas, New York, and Florida. And if you further narrow it down by apartment by units in structure, you could see that a 50 plus apartment unit makes up a larger share in the market, with almost 35% having 8 million apartment units, and closely followed by a smaller apartment unit with like 5 to 9 units and 10 to 19 units, which approximately make up like 5.5 to 5.3 million apartment units. So the stock is really growing. And when the stock is growing, there's also a question of the basic necessities one would require living in that apartment unit. And water heating definitely is not just a basic necessity, but a major necessity as well. And if you talk about the fuel that is going to be the primary preference for water heating, fossil fuel and electricity definitely stand out. And if you just come back to electricity and concentrate more on heat pump water heaters, the in-unit and central system have a sort of a fine balance. So there are some regions that prefer an in-unit heat pump water heater, and there are regions where a central heat pump water heater would work well. And it's just not regions. I also believe that there could be a diversification given the multifamily building units in itself. Like it could be a low rise, a small commercial, or it could be a medium rise, large commercial multifamily building. And a central heat pump water heater system really works well for large commercials. But if we just want to concentrate on like what could be some of the innovative ideas that we could explore and find a way to fit them in a multifamily building unit, especially like a low rise maybe, or a small multifamily building unit for the beginning or for the initial experimental stage, what could really work well? And there are ideas, some of them that I really found interesting and I wanted to share. The first happens to be a combi heat pump water heater. If there is a scope and opportunity to have space conditioning and domestic hot water at the same time, then why not? There are products here which can simultaneously provide heating, cooling, and hot water production to residents in a multifamily building space. Now, within this combi system, there are two types, a monoblock system and a split system. A monoblock and split, as the name suggests, again, very simple. A monoblock is a single unit that has all the necessary components for the heat pump water heater. They are factory sealed refrigerant, so there is no issue of refrigerant leak. They have a glycol water mixture to help the refrigerant overcome any freezing issues when the temperature drops. In split system, there is an indoor unit and an outdoor unit. In monoblock, it's just one unit. And the fun fact here about these combi heat pump water heaters is, at least for some of the manufacturers, as I know, Stable Electron, Chiltrex, Spacepack, they all happen to be add-to-water heat pumps, which means that they really have a good market scope in replacing boilers in existing buildings uh, where there is a hydronic system in the architectural design. They also work well with new construction, which has a hydronic system in place right before the construction begins. So here is a scope, definitely in the markets for a combination of space conditioning and hot water system at the same time. And with respect to combi heat pump water heaters split systems, we have Hitachi's Yutaki S series and LG's Thermavi split. LG's Thermavi split could also be a wall-mounted hydro box apart from a flow-standing piece. And Hitachi's Yutaki series, as they say, it is small enough to fit in confined spaces. So in multifamily buildings, space constraint has always been a challenge. So in that scenario, products like this with innovative solutions work well, not just for hot water production, but also for space conditioning. And, and as we continue to talk about split system heat pump water heaters, at the moment we do have two manufacturers' products out in the market, Sanko's Eco2 system and Smart Solar heat pump water heaters that work efficiently well in multifamily buildings, providing hot water to the residents. And if you just have a look at the global market, we have some other interesting products as well in split systems. Edison has a Nuos, a series. Haier has a split system spread across Europe. Chromagen Media has a good market share in Australia. And my personal favorite is Rheem plus Sandon in New Zealand. They have collaborated bringing out Eco Plus hot water heat pump system. Keeping fingers crossed that Rheem plus Sandon should also venture into the US market soon. Other than that, we do have an emerging new product, Embertech, which hopefully would again reemerge with new upgrades in 2025. They are available as of now. They are available in like 41 gallons and 75 gallons. But yes, there is something coming out in the split system market pretty soon. Now this was about like combi systems, split systems. Moving to the next section, which is also my personal favorite. I guess I have a penchant for things that seem slightly impossible. So wall-mounted heat pump water heaters definitely came out something interesting during the research. We do not have a market scope here at the moment in US. There are challenges, and I think there are certain areas that need to be understood before this could actually venture into this residential multifamily building space, or even for like single family homes. But there are certain products out there in other regions doing well. So let's just have a glimpse of what is across Europe, Australia, and Asia. In Europe, there are different manufacturers. I just picked out two just for the slide here, Ariston and Daikin. Ariston, apart from having a unitary system in US, split system in Europe, they also have a wall mount Novus Primo series and Evo split series in which is spread across in Europe. Daikin has Daikin Altherma 3, which is a split wall mounted unit. They have been doing well in the Europe market. I think there was also at one point there was some discussion going on for Daikin to be venturing into the US market. I do not have a latest update on that, but let's keep fingers crossed that at some point we might have a wall-mounted unit in US. And for wall-mounted heat pump water heaters in the Asian market, A.R. Smith has, in their own words, world's smallest heat pump water heater. They are doing pretty well in the Asian market in Singapore. Apart from that, there are some others that I came across, Solar East with Sunrain and Secon, Gomon, Theodore, and NB Wave. One common thing about these Asian heat pump water heaters was like, particularly about Gomon, Solar East, Theodore, and NB Wave, that the warranty period here was 3 years. And that is the difference compared to the heat pump water heaters in US, since we go with almost like 10 to 15 years of warranty period. Other than that, the configurations, the refrigerant, the voltage requirement, the storage tank, all of these seem to be almost like in a similar configuration as we would expect in the US market. In the Australian market, Thermo has a wall mount heat pump water heater. It's in liters, 100 and 150, which is close to like 40 gallons as per US standards. So this was something about like wall mounted. So we do have some innovative solutions that could work well for the multifamily building units, combi systems, split systems, heat pump water heaters, wall-mounted heat pump water heaters. And at the moment, I'm also trying to look into the scope for replicating the central heat pump water heater system that has really worked well for large commercial multifamily buildings. But could they be transformed into a small semi-centralized system and with in-unit storage tanks and residential units that could work well for low-rise multifamily buildings with like 2 to 4 apartment units? But that discussion is for the next time. But for now, just leaving a food for thought and setting up the platform for the next presentation. All of these ideas theoretically look good enough to be explored, to be experimented in the multifamily building space. But what really happens when we do the field testing and lab testing? What are the challenges that we might come across? What are the areas of concern that needs to be identified, acknowledged, addressed, and reworked so that we could maximize the impact of making water heating space more energy efficient? And for that, I have the next presenter, Doug Lindsey, share his insights. So on that note, I'm going to wrap up my presentation, take a step back so that Doug could come forward and share his presentation. So thank you everyone for your kind attention. I wish you all a great rest of your day.
Awesome. Thanks so much, Vidhisha. Great. All right, we'll go back to our slide deck. Really appreciate that walkthrough of some products that might work for this multifamily space, the in-unit replacement. So yeah, Doug, let's go over to you. I'll get our slides loaded up here, and then I'll have you take control of the screen. Yeah, perfect. You need to flip through a couple slides there, but this will be the deck that we'll send everyone later, the slides we just saw with Vidhisha. But Doug, thanks for being on, and yeah, great to have you on. Go ahead.
Thanks, Joe. And Josh, I see your question. I'll give one example of a test that we did with one unit here in a minute, but thanks everyone. My name is Doug Lindsey with EPRI. I'm going to be talking about some of the work EPRI has done in the past 4 or 5 years, actually, around the topic of what other products are around the world related to heat pump water heaters. I'm going to be focusing today on wall-mounted because that's what Joe and Kashmir asked me to focus on. But we did some of the same work that Vidhisha was talking about in terms of looking around the world, what is out there. And this was back in 2020 that we started this work and reported out to our utility members. So all of these might not be up to date still, and there's probably a lot of new ones that we don't have on this list, but Back in 2020, these are the ones that we identified, and these were just heat pump water heaters of any style. They could be split, standalone, floor mounted, or wall mounted. But just to give a picture of where we looked and what we found. But I want to just kind of dive into a little bit more of what Vidhisha was talking about related to the styles and how they could apply to the US. We did a feasibility study as well on these styles of wall-mounted units, and I'll have some results from that to talk about. But first, we looked at these horizontal style sizes, which are very unique. Certainly something that we haven't seen before in the US market. And they're wall-mounted horizontally with the integrated heat pump. So it's certainly something that's, I call it similar in form factor to a mini split on the wall, putting that up high somewhere out of the way. People are beginning to get used to that in the United States, and most people don't even notice it anymore. But that's not to say all the pictures that you see of these don't show the water pipe connections. And that's one thing that I wanted to talk about. A lot of these have bottom or side water connections that are not easily hidden. And if you're going to have a water heater in the occupied space, which is where most of these currently are in Europe and Asia, that's something that we'd have to deal with. It'd be another visual impact of the unit. While a lot of these do look very nice and high tech, have screens on them, you'd still have to deal with the pipes, and that's something that can be dealt with, but certainly would be different from what we currently have in the United States. These are particularly small, 16 to 21 gallons in size, and that's certainly a big change for the US market as well, while most of our units are 40 or 50 gallon size tanks. So in some cases, you would probably need 2 of these in an apartment unit. Maybe one for the bathroom, one for the kitchen and laundry. That's just theoretical. So we also looked at the vertical styles, and we actually brought some of these into our lab. We didn't buy any of the horizontal ones, but I'll be talking about some of the vertical ones that we tested as well. These are much various different sizes, 20 to 40 gallons is what we saw. Of course, all of these are in liters, but we converted it to gallons for our audience today. But these had more flexibility, more different unique features. One unique feature that I really liked was the concentric duct design of one of these, where it had the outside air coming in and also being exhausted to the outside through a single pipe, which was pretty unique and would be very helpful for installation processes to be able to have a single pipe outside. Almost all of these had recommendations for venting either to another room or directly to the outside, so you don't introduce a lot of cold air into the space. That's another thing to think about with climate. How much do you want to pull out of the space, and how much do you want to exhaust outside? That's another concern that I think all of us still have around heat pump water heaters. But these were very unique. The water connections are on the bottom for most of these. We see some have the heat pumps on the top, some on the bottom. That is another consideration. All of these had a resistive element, a single resistive element. As you know, they have 230 volts throughout most of the world. But these were 1200 watt elements, so also didn't heat the tank exceedingly fast. So that's something to think about as well. So I mentioned we did bring one of these into our lab. This was the Vestherm propane refrigerant unit, and we specifically picked it out because it has propane refrigerant, and that was one of the unique things that stood out across all of the units. We did find most of them were 134A or 410. This was back 3 or 4 years ago now, but we found this propane unit and wanted to bring it in. This was the larger version of the 2 that they offered. It could be floor standing or wall mounted, and capacity of 47 gallons. This was one of the ones that was designed to be at least one duct outside, however you choose, but it didn't have to be. Water connections on the bottom is a unique thing, an interesting thing that I don't think the U.S. market is really ready for yet, but it's not a deal breaker, but it definitely made it harder to install, and you have to have a lot of turns in your fittings, and was a little bit more of a challenge. This one had a single 1800 watt element. Of course, it wasn't UL listed. It wasn't designed to be sold in the United States. They did not have any of the UEF or FHR ratings done or claims, because it wasn't made for the market, but they were happy to sell it to us to explore potentially future markets. So these are the test results here that we did in our laboratory, getting a 3.0 standard UEF, which I thought was pretty good for this unit that wasn't designed for the UEF test. The FHR was basically whatever the tank had in it, so 36 gallons in that first hour. It did not recharge within that 1 hour to be able to draw any more hot water out of it. So that's another thing to think about when we look at a lot of these wall mounted. You're probably only get the 75-80% of the tank rated gallons for a first hour rating, which is pretty small for the US consumers. We're not used to that. That's why I said in some instances you might need 2 of these in a single unit if you wanted to. Maybe if it was a single studio with 1 person in it, they could get by with 20 or 30 gallons of hot water. But I think for the average American who's used to a natural gas or even an electric that can recover within an hour, it's definitely a unique challenge to think about. So in terms of our feasibility assessment that we did in 2021, and all of this was done, kind of before the commercialization of the 120 volt heat pump water heater, which was one of the reasons that we were looking at this, is to try to understand different form factors, small sizes. A lot of these things were solved with the 120 volt heat pump water heaters that have come out in the recent years. But, thinking about the small size of these was something that would require a lot of shift in the U.S. market. Customer thought of how to use a hot water and how to limit your usage of it. None of these had UL listings. Obviously, they aren't optimized for the UEF and FHR testing as the United States products are. But that is something that the manufacturers could undertake if they so chose. We did want to think about, the integrity of the walls that they're mounted on. In most of the examples, at least the documentation that we saw, they're talking about mounting bolts into blocks or cinder blocks or some type of brick. Most of our interior in the United States is, sheetrock on wood studs. I'm not sure many of them were designed to hold 40 gallons. So that's something that there needs to be some structural integrity assessments done before I would put one of these on a wood wall. Not saying it couldn't be done, but it's something that a consumer would have to think about and a plumber would have to think about as well. Cost and constructability. So there's definitely, we thought you could probably save some space mounting it on a wall. Definitely for the horizontal ones, you could save some space, but we found with, bottom water connections, these could not fit any better in a closet than our current 120 volt heat pump water heaters, in my opinion. So it wouldn't really be that much better for a tight space, and that also restricts the airflow, as we know with heat pumps is a challenge. So one of our conclusions and recommendations is that there would be a lot more research that would need to be done for U.S. customer acceptance of a style of heat pump water heater like this, and also putting these in common spaces like bathrooms or kitchens where you currently might not have the plumbing accessible to connect to, would be another installation challenge. So there's several things to think about here. It's an interesting idea, maybe not ready for the U.S. market, but interested to hear other people's thoughts and opinions. So I'll stop there and see what questions we have in the chat.
Thanks, Doug. Yeah, we've got a couple. So yeah, first, I guess do you know how much propane is in that model that you highlighted the slide before?
Yeah, 140 milliliters.
Okay.
Yeah.
What that equates to as far as grams go?
I think that's the same as grams.
Okay.
So it is higher than our limit in the United States.
It's close.
It's close though.
Yeah. The operating range, someone was asking about that.
I do have that. I don't have it on the slide. I'd have to go back and look, but I think it was standard, same ranges that we have for our heat pumps.
Got it. That's a big 47 gallons is a lot. I mean, you can buy a 40 gallon, but that's a big standing wall mounted one right there that you're showing.
Yeah, I wouldn't put it on a wall. They that made the 20 gallon version. We just bought this one because we thought it would be more acceptable by the US market.
Yeah.
Mm-hmm.
Josh is asking if you measured how much cool air was exhausted over a 1 to 2 hour period.
So asking about the tonnage of the heat pump, I guess. Yes, we did measure that. I don't have a number off the top of my head. I'd have to go back and look. The heat pump was a larger compressor than I think most of our current water heaters are, so it did recover faster. But I don't think I converted it to tonnage, but we could.
Yeah, well, I guess in your thoughts, Doug, I mean, it seems like a little bit of skepticism whether this would work as one of these multifamily in-unit replacements, at least for the wall mounted.
Yeah, I'm really just not seeing that many advantages over our current ones that we offer in the United States. You know, it's interesting to be able to put it, if you're going to put it in the closet that we already have water heaters in, I'm not sure why we would need a different style of or smaller size. With what we currently offer today in the market. But if you're going to put it in an occupied space, like a bathroom or a kitchen that's not in a closet, that's a different market, I guess, and one that I'm not sure. It would have to be likely a new construction to put that in effectively. I'm not sure the retrofit market would be acceptable for that.
Cool. Okay. Well, thanks for that. There's one more question Josh put in the chat about sound decibels, if you measured that.
I did not, but this one was not any different than our typical heat pumps. No.
Yeah. Great. Well, thank you for that. Great. Okay. Well, thanks, Doug. Appreciate it a ton. Let me take control of the slides. Yeah. Thanks to Doug. Thanks to Vidhisha. It's an interesting thought. Some of these, what are these in-unit replacements going to be, and what will work over here compared to what works over in other parts of the world. So really appreciate that look, all. I'm going to move us onward to our next presenter, Amir Habibi from Solaray. Talking to us about their solar thermal water heater and how that might or might not be paired with heat pumps. So, Amir, if you want to take control and turn your camera on. Yeah, perfect.
Awesome. Thank you so much. Well, first of all, I wanted to thank HPWH for having me. I think it's really important for us to have these conversations about how these different technologies can come together to help us achieve the goals that we have, both for decarbonization and electrifications across different industries, including multifamily housing and residential. So I'm going to give you guys a little bit of a background about Solaray Corporation. Solaray was established in Hawaii in 1975 and basically currently is the parent company of Sunert in California and AET in Florida. Both companies manufacture solar water heating equipment since the 70s, basically, give or take. For Sunert, it's since 1978, and it's about the same time for AET as well in Florida. And they both focus on manufacturing solar water heating solution around the flat plate collectors, which we'll talk about a little bit later on. The company currently has 7 locations across Hawaii, California, and Florida, and we are at 100% ESOP with over 100 people, employee owners. There's a lot of experts on this call about the heat pump water heating. In my experience, solar water heating is not as known, so I'm just going to go over a little bit of the basics, and talk about a little bit about the different components that goes into a solar water heating system, and then I'll jump right into how these two systems can potentially come together and a little bit about the emerging technologies that we're seeing with the demand for electrification and decarbonization, and how these technologies coming together can put us over that hurdle. So generally, when we're looking at solar water heating system, there are three main components that pretty much repeat themselves across different system types. There is always some sort of collecting, a collector component, which basically helps collecting the solar energy and converting it into basically transferring it into a heat transfer fluid that can then be stored later on. There is a solar pump station. There is some sort of a heat transfer mechanism, basically, to take the heat from the collector and store it in the solar storage tank. And there is always some sort of solar storage tank. We can categorize these systems into a couple of different main categories. There are direct systems and indirect systems. And then there's active and passive systems, basically. When we're looking at active versus passive systems, whenever we have a moving component, such as a pump, basically, you're dealing with an active system. And then whenever there are no moving components, such as a thermosiphon system, which, as the name suggests, operates based on the thermosiphon effect of heating fluids, there are no moving parts. So that's one main category of differentiation between different types of solar water heating systems. And then there is direct versus indirect systems. Looking at the market worldwide, the largest number of installation that we see on residential are direct thermosiphon systems, because especially in areas of the world where they are not as developed, or basically energy is very expensive, direct thermosiphon systems are very popular, and you probably have seen them in parts of the world on rooftops with the tank attached to a couple of collectors below it. And it just takes advantage of free solar energy to provide a substantial amount of hot water. But when we're looking at centralized systems, especially around multifamily designs and usually larger commercial applications, we are 99.9% of the time, we're focusing on indirect systems, and then we're looking at active systems. So active indirect system is what we see the most, and that's just because how the systems are designed and then integrated. Solar thermal systems, the way that they're designed, they can work with pretty much any type of a backup or parallel heating solution. But when we look at them and how they could possibly integrate with heat pump water heating systems, we see that they have a lot in common, which kind of makes them a natural pair, so to speak. So both of them are designed to accumulate heat over time, store it, and then dispense it on demand. And solar water heating solutions always require a backup, because we always have to account for those periods of time that there is no solar energy available for whatever reason that might be. No matter what area of the world that we are operating on, we cannot guarantee that there will be 365 days of sunlight, and we always have to have some sort of a backup solution, because we have to continuously provide that hot water to the building. As we have seen, it doesn't even need to be necessarily clouds. There has been cases that excessive fire in an area has blocked the sunlight for prolonged periods of time. And if that's the case, you still have to have a reliable backup system that can provide the hot water. So pairing these two systems has a lot of advantages when we're looking at them from different angles. They both need some sort of tank, some sort of a storage, a thermal storage, to basically store that accumulated heat so you can dispense it on demand. And because of that, with a little bit of a control programming and a little bit of a design work, we can have these two systems come together and share that storage tank and take maximum advantage of it. Solar water heating systems operate on a very high COP in general, because again, in commercial systems, as I mentioned, we are dealing with active indirect systems, but in that active system, what you're actively basically operating to gather all that thermal energy and transfer it to that storage tank is a small, relatively speaking, small circulating pump. So that helps a system to have a very high COP. And then when we combine this with another high COP backup system, we end up getting an overall extremely efficient system for water heating solutions, especially when we're looking at electrification of the buildings. A lot of times with complete electrification, there are issues with operating the service, electrical service to the building, stuff like that. Combining these two systems together also could have an impact on that. With the extra solar energy coming in, there's potential for downsizing your heat pump water heating system and kind of try to avoid some extra costs that will come from major upgrades that would be involved, basically. So I want to kind of showcase a couple of systems that we already have in operation. These are the systems that went in 2024, and we're monitoring them to have more and more data on the performance of these systems coming together. Basically, our annual energy savings that you're seeing from the solar thermal system is based off of our energy projection, but we are constantly verifying this information, and I'm glad to report that so far things are looking good, and we're looking forward to put these into a formal study and put it out there in somewhere in 2025. But with these particular systems, we had solar thermal and air source heat pumps working together, and basically we can see that the daily hot water demands that we had from this commercial buildings in Columbus, Ohio. Due to some NDA agreements, I have to be very, very vague about the type of the building and the nature of the operation. But in any case, we have the hot water demands and the temperature requirements from these buildings. And the systems were designed to have a relatively speaking lower solar fraction, just helping as much with reducing the cost of operation. And as we can see, that those numbers in annual energy savings coming from the solar thermal water heating system can really have an impact, especially if what we're replacing is, electricity, which in some areas tend to be the more expensive fuel. Then that will really help with the OpEx side of the operation for these systems. As we're moving forward, we're seeing a lot more of innovations coming from different solution providers and looking at different combination of the systems that could work together. We're seeing solar water heating system working as the preheater for multi-stage air source heat pump. You're seeing solar water heating working in parallel, as I mentioned earlier, with air source water heating heat pumps. And then a very interesting solution that's been developed recently, and more we're seeing it, is use of basically solar thermal as the heat source for a water source heat pump, especially for high temperature water source heat pumps that we're seeing coming out of Europe that can reach temperatures in excess of 260 degree Fahrenheit with source side at 90 degree F, which is a temperature that solar thermal can constantly provide. So there's a lot of, again, as I said, areas that combining these two systems, can benefit the system owner. There are instances for solar thermal that there is not enough space on the facility, especially commercial facilities. Some industrial application, we're seeing more and more of these, that the space is a limiting factor, especially some of these buildings that have a lot of other HVAC equipment on their roofs. And then combining solar thermal with the air source or water source heat pump as the backup source can help us also optimizing the size of the solar array that we have to deploy. And then in some applications, especially in areas that there are geothermal systems active, you're seeing bringing all these together and having multi different load basically sources for the heat source for that water source heat pump to operate at a very high COP year round to provide either hot water or low temperature steam, depending on the design and the model of the heat pump that's being used. But again, a lot of these existed as concepts for a very long time, but it was always considered non-cost effective when it was running against, relatively speaking, inexpensive natural gas. And the trend is changing, and what we're seeing is not only electrification, but also decarbonization is playing a big role. And that basically elimination of the access to that inexpensive fossil fuel has opened the opportunity for a lot of these concepts to now be considered and basically be deployed as an actual solutions. And for what I was mentioning earlier, for those high temperature water source heat pumps, we have some pilot projects that are set to go in early 2025 in New York City, and we're going to publish more information about the performance of these two systems coming together and how it will impact basically the overall COP of the system and energy delivery and savings. So at this point, I tried not to go too long about solar water heating and kind of have some time for Q&A.
Thanks, Amir. Yeah, that was great. There's a lot there, a lot to talk about. Really fascinating stuff. So folks, please feel free to put your hands up. I had some questions to get us started, but just really interesting, this idea of solar thermal preheating the water for for industrial high heat applications. Are you seeing that so far just in Europe, or is that what you were referring to as maybe some case studies in New York City?
There are some commercial case studies going into New York City for that kind of an application, and figuring out again, mainly because the controls of the heat pumps are more sophisticated compared to the control requirement that we have for solar water heating. It kind of falls on the solution provider on the heat pump side to have the right solution to control these better, to work optimally together, because there are times that you can get directly to high temperatures. Let's say you have a target temperature of 140 degree F, you can go directly with solar thermal, and that will get you a COP of probably mid-teens to mid-20s on average. So that should be your basically option one. Then go into option B and C and D, depending on the order of priority and energy availability. But because we are seeing now there's more willingness to adopt those, because the solar thermal part is, as I said, is relatively simple. So you're seeing more willingness from the manufacturer, from heat pump manufacturer, to adopt that side into their solution.
Great. Abby Dakin said, can these systems at the residential scale be rated with SRCC 300 to get SUEF?
I would believe that OG 300 would basically rate any systems, including a heat pump. That's definitely something that I can reach out to SRCC and Sean Martin and their team and see what their response would be. But I don't think they would have a fundamental issue, because it should be just as easy as any other sort of a backup system working. Just will have a much higher UEF probably.
And then question on the equipment costs. How does this, especially when you have these combi systems already in the heat pump world, we're dealing with having to overcome some higher equipment costs and making things pencil. How does it, in these initial case studies, like the one in Ohio or the ones you're exploring in New York or have seen in Europe, how are folks getting over the equipment costs of pairing maybe two more expensive systems than the traditional fossil fuel ones?
Well, both systems qualify for the IRA, either under tax credit or direct pays. And then there are some solar specific rebates depending on, what type of industry and which area of the US we are operating in. But mostly is, once we're looking at the systems with, if the commitment is there to, either go with an all electric solution to begin with, or switch to an all electric solution because there is a greenhouse gas reduction motivation or electrification requirement, for one reason or another, then adding the solar thermal, it does increase your initial investment a little bit, but then it will really help with keeping the cost of operation down because it's a solution that is generating energy on site at a very high COP. So that really comes into play when we're looking at combining these systems together. And there are a lot of cases in retrofit cases. Let's just say sticking with California for a moment. Under the CSI thermal program, thousands of solar thermal systems went in on multifamily apartment buildings. That most of them are operating on gas boilers. So now a lot of those buildings are now looking into electrification. So with that reason, there's a huge opportunity there that there's an existing solar thermal system that will continue in operation for the next 10, 15
I'm
years.
sorry, Amir, could you hold on a second? I'm looking for, we're getting, can folks make sure they're muted? I think I found the culprit there, but if folks can just make sure they're muted. Sorry, continue, please.
Oh, no worries. There's a lot of retrofit opportunity. That's what I'm saying. All these solar thermal systems that were installed within the last, let's say, 5 to 10 years, and they have a life expectancy of 20 plus years. They're already going to be on these buildings. Now, some of these buildings are looking into electrification. So the heat pump is coming in. So if you have a solid solution on how we can, if there's an existing system, how these two can, work together to even further reduce the cost of operation for this all electrical system, making it even more interesting for the building owners.
Great. Well, thank you so much for that. Any final questions? We're a little behind time here, but still have a good half hour in a meeting for Todd and our final presentation. But any last questions for Amir and this fascinating study on pairing solar thermal and
Absolutely, my pleasure. I'm going to put my contact information in the chat if anybody has any questions, if they want to look into some simulations and consider how these systems would pair together, or they want us to share the results of our studies and the white papers and stuff that are coming out. Please let me know, and I'll be more than glad to share more and more information with them. I'm going to post everything right in the chat. And thanks you all again, Amir, for this opportunity.
Yeah. I really appreciate it, Amir. Thanks for coming on, and we really want to keep in close touch as you're studying this pairing. We're excited. So yeah, thanks
Absolutely.
for coming. Let's take
First and foremost, we want to be your source of information for solar thermal. So anything, just please feel free to reach out to us. Thank you.
Sounds great. Well, I'm glad we connected. Thanks so much. Really appreciate it.
Thank you.
All right. Well, we'll go to our final presentation for today. Todd Amundsen from the Bonneville Power Administration is here to talk to us about case study for central heat pump water heater in the Northwest. Todd, thanks for being on, and go ahead and take it away.
Yeah, thank you for this opportunity to present. And yeah, we are here today going to present out on a City of Longview, Washington, YMCA commercial heat pump water heating project. It's still underway. It may be a cautionary tale, but one that hopefully will lead to good results and learnings. We're not there yet. I'm Todd Amundsen.
So I'm sorry to interrupt. It looks like I stopped sharing. So let me get the slides back up here. Here we go. Sorry about that. Okay, do you want to take control again? Sorry about that.
That's all right. Good. Great. So yes, we have parties involved, the Longview YMCA, Cowlitz PUD, BPA utility customer, Bonneville Power Administration, and contracting we did with Ecatope for their expertise in heat pump water heating systems. It was we'll review the project today. It's a multi-year kind of lifetime, and have the project proposals were iterated over that time, and how the facility proceeded with a different system than what was earlier proposed, and some issues we're experiencing and some next steps. So again, thank you for this opportunity to present on this project. Just a bigger picture, BPA, Energy Efficiency Emerging Tech Program, wants to research the commercial heat pump water heating systems in various areas, as you see here. And, working with the YMCA in Longview is one of the number of research projects underway in our large service territory. So, the Longview YMCA, kind of the vintage side where this building has been in place since the 1920s, and there's been some modernizations over the year, but You know, this one side of the building has a dedicated heat pump water heating system that was previously and still presently served by a Rayovac natural gas boiler, about 500,000 BTU per hour capacity. And the YMCA and many of our end use sites want to transition from natural gas to a cleaner electrical energy solution. So we were brought in by Cowlitz PUD to explore even higher efficiency electric solution options. So we deployed meters and looked at how much water and temperature needs or uses of that system, and was able to kind of baseline that natural gas system and do some analysis on what would it take to transition that to the hypothetical electric resistance water heating system, and transitioning that furthermore to deploy a higher efficiency heat pump water heating system. So EPA did the metering, and we shared much of that data with all parties mentioned, particularly Ecotop, to do the analysis and come up with some proposals for the YMCA to solicit bids on. And the YMCA did that, and the bids came in a little bit higher than what was expected, which kind of had to reconvene and figure out, with their budget, what could they do that could still meet our energy efficiency program needs and, meet their system on that side of their building as well. So, BPA and Ecotop reviewed the design and met with Cowlitz and the YMCA, discussed, and later reviewing what was installed at the site. So this picture shows the original proposal by Ecotop with 2 Sandco units kind of designed and located outside of the building, and providing hot water to storage tanks. And in addition, there's that electric resistance water heater that provides plenty of capacity to meet the needs on that side of the building. And also discussed what we find in place at these sites. A lot of recirc loop piping was non-insulated, and just kind of opportunity there to improve that and all. But with that design, was again meeting the site where they're at, and not being able to spend as much on as the Ecotop proposed system. What came into play in various iterations, number of residential heat pump water heaters shown here changed over time, and number of electric resistance water heaters changed over time. But this is presently what is installed, the YMCA. We have 3 Ream Proterra residential units, 50-gallon capacities each. We have A.O. Smith 120-gallon electric resistance water heater in place, and they still have the Rayovac unit piped in because there's just been issues in meeting temperature needs of the facility. And probable cause, as identified early on and recently by Ecotop, is this large 1,000-gallon existing storage tank that's horizontal and not an ideal tank that would kind of meet the stratification desires or technical requirements that Ecotop has identified early on. So we've also found that in comparison to our metering that took place in 2022, year 2022, and what has been, of course, metered in April through November of 2024, that the water demands have almost doubled for this side of the building compared to, the baseline period. So we're exploring that with the YMCA as far as kind of what might have changed between then and now and all. So kind of looking at different iterations of the savings, because of course we're in the electrical energy efficiency saving world, and looking at, you know, what could have been an electric resistance water heating system to this alternative heat pump water heating. Yes, thank you. That it's possible. Yeah, a little more usage since we're a couple years out of the pandemic. That is kind of our perhaps understanding as well. But yeah, the savings just in the heat pump water heating system were in the 29,000 kilowatt hour range, a little higher for the highest efficiency Sanco units, but still very respectable savings for the proposed alternatives. And we also quantified savings in, just by upgrades to that recirc loop, primarily insulating, where a lot of heat is lost in those piping systems in an uninsulated, unheated basement area. So, and those have not been implemented yet, which may be part of the, potential solution to this issues. But yeah, this kind of weighing the risks before we proceeded with this project, reusing that big storage tank, stratification issues and losses, it's minimally insulated. And, of course, the lower upfront costs of reusing the piping and the tank and all. But the risks noted here, an unproven piping configuration, we're relying on a consistent room temperature, which really hasn't been an issue. I'll show you some temperature data logging in the next slide. And the black box, we haven't had any issue with that certain type of residential heat pump water heating, at least nothing to date yet. Legionella has not been identified as an issue to date yet. And maybe there has been some limited capacity with the sustained domestic water heating use, as they have had to rely still on that Rayovac natural gas boiler to boost temperature needs up. But still, we've seen some successful running of the the heat pump water heating units, and it's kind of an eyesore perhaps, but it's does represent data logging from April through November. And we see on the left there, the water supply from those 3 heat pump water heating units is ranging from about 95 degrees to 130 degrees Fahrenheit, averaging about 120 degrees. So that's significantly saving on the natural gas consumption of that existing boiler, but it's still not enough, as the electric resistance water heater hasn't been put to use because of not meeting hot water needs. And the right side here shows various temperatures. In orange, we're seeing kind of the ambient air in this basement area where the heat pump water heaters are located, going from kind of 62 degrees to 74 degrees. We're seeing the recirc temperature ranging from about 80 degrees to 125 degrees. And then we're seeing kind of where that heat pump water heater supplies the bottom of that large tank, going from 90 to 130 degrees, and the top of that large storage tank kind of ranging from 125 to 130 degrees, which is respectable. But again, we're seeing so much a drop in that recirc piping that they've had to still resort to using the natural gas. So all this was identified in the fall, and we were able to reach out to Ecotop and have them kind of do a video site tour with our YMCA contacts and kind of take all that information in, and as well as the sharing of the data. We shared that with Ecotop too. And they kind of provided these bullets of opportunities to improve this existing system in the following ways, which would allow them, again, to turn off that natural gas water heating unit. And, the inlet connection from the, domestic cold water from the city to the YMCA is directly fed into the heat pump water heating units. That's, a lot of work for those heat pump water heatings when there's high demand. And that's noted in that second bullet down. And, the heat pump water heaters aren't able to provide heat to the storage tank when there is no domestic water heat usage. So a lot of surface heat loss and recirculation heat loss, can't be made up by these heat pump water heating units. And again, when there is high domestic water use, cold water flows direct into those heat pump water heating units. And if we could get that stratification in that tank successfully, work, that would, reduce the demand on those domestic water heating or the heat pump water heating units. And, the electric resistance elements could work better as well. And it's a lot of words here, and maybe you can digest these after the presentation and reach out. Be glad to discuss these with you further. But replumbing of these kind of the piping came up as an opportunity, and not a cheap one. That was, again, our YMCA staff kind of are still kind of mulling over how to do this with the budget that they have. But clearly these are opportunities that hopefully we can at least find some happy medium to address. And again, Ecotop did a wonderful, timely response memo that this little graphic was copy and pasted from. It's a lot to digest here, but adding a mixing valve, that was one that we may not be able to meet YMCA cost budget for, but it certainly would help. And some of this recirc pumping between the storage tank and the heat pump water heaters was identified. And doing some, again, better piping to meet stratification needs in this large 1,000-gallon storage tank could hopefully be sufficient for the capacity of this system in place working to be able to remove any needed usage of that natural gas heater, which will probably be retired in place down there in that basement area. But again, more solutions noted here by Ecotop help that tank stratification, swapping the inlet and outlet connections that are currently in place for the water heating system, so they can pull from the bottom of the tank and return that hot water to the top of the tank, and routing city water to the bottom of the tank too, and installing recirculation pump that would allow heat pump water heaters to heat directly from the bottom of the tank. So some of those things I already mentioned earlier. And looking at pairing recirculation pumps, this aquastat control would be a great idea. It would require some drilling and installing to kind of control both sides of the electric water heating systems for the heat pump water heater and the electric resistance heaters. So we're gonna revisit this again with the YMCA. We're at this point, I think I saw my colleague Kashmira raise her hand. Joe,
yeah, Kashmira, go for it.
Todd, thank you. And I'm sorry to pop this question on you because I did not think of it ahead of time to prep you, but I'm just curious. how does it affect rough order of magnitude, right? Like no real math. Like what is your thought on the cost of these errors and rework versus the cost of the system? Like, do you think it's a third, a half? I have no idea. Like, what do you think?
I'd say roughly a third to a half of what they've paid so far for this system in place, which is in the, I want to say $10,000-15,000 range. We've had no bids or quotes, and that should be something we pursue next, or suggest the YMCA pursue. This is fairly still hot off the press, this ecotope analysis. So we need to, there's still more steps to be had. But yeah, the repiping is probably in the $3,000-5,000 range, give or take 50%, I'd say, in my estimate. That Sanco system that was earlier proposed, kind of like the Cadillac system, that was in the 20,000-25,000 kind of proposal range. And when YMCA went out to bid, that cost was 4 times that. So we're still significantly below what they were finding for costs to install the the Sanco system. But it's still the limited budget of the YMCA that we're kind of dealing with. But we'll find out more as these bids come in for
I wonder why, Todd, and I think John Heller's still on. Why would it have been so much more? Go ahead, Kishma.
Well, one thing I was going to say is to do a shameless plug for the QPL. It's not the widget of the compressor necessarily itself. It's how these pieces come together. And the YMCA, like several of our other customers that have used outside firms that do custom engineered projects, design projects, I think that there's a real risk in so many little pieces, like the tank stratification or balancing valves or how recirc is set up. And I think the QPL offers a specific design guideline that is either specified or fully packaged to build a system. But
it was $100,000.
I'm sorry to cut you off, Joe.
But it was so much more expensive. It seemed out of reach. I wonder, is that, John Heller, do you have any thoughts on why that cost was so high?
I mean, we've run into this in other cases. It's because the fully packaged integrated units are so easy and they look like a water heater. And so the plumbers, they know they can just stick this thing in and hook up the power and the water, and and that when they look at a split system, it just makes them nervous. Like, okay, I've got to figure out a place to put this outside unit. I've got to figure out how to pipe the water over to the tanks. I've got to it's not hard. I put one in myself in my triplex, but somehow when you've got multiple parts, the prices are quite a bit higher for that labor. I don't think they should be, but I think it's just because it's an emerging market.
Well, and the other thing is this was very early COVID when we scoped out this project for the YMCA. Like it might have been all the way back to 2020, 2021, right? So I don't know how the market has changed since then. I know we have a lot more players and we have a QPL that has design specifications, but I just wanted to do that shameless plug because it's costly. These mistakes are so costly.
Yeah, I think that's exactly right, Kashmira. This is why we have the advanced water heating spec and why we've kind of standardized these design approaches around systems that have been proven. Because not to say that you can't develop a custom design, it's just a lot harder to make it work well. And there's a lot of mistakes that can be made.
Todd,
Thanks, Todd.
Thank you.
I just wonder, with with what the YMCA was facing, say they were facing $100,000 to do it the right way, or did they end up? It was from understanding it was $15,000 for this kind of. But then they're having issues ahead of time. So that's still. So
now they're
that's a tough
20K,
choice.
let's say,
Yeah,
just rough
yeah.
math, right? But 25K was where they were before. So how much did they lose in that, savings of design and energy savings and performance and cost of repair? At one point, do they get kind of close? It's just the rough math.
Yeah, and we hope to report back to you on where we land. Hopefully, it'll be a happy ending, but we are to be determined.
And Todd, I didn't totally get that. I mean, there were these projected savings, but are they seeing energy savings with the current setup despite the problems?
Yeah, they are. They are. We don't have any dedicated meter on that natural gas boiler that's still in use, but doing some kind of energy engineering analysis of delta T's and flow rates that we do have, they're saving relative to the electric resistance baseline hypothetical. They're saving in the ballpark, but there's still that somewhat small amount of natural gas heating to boost that temperature up. So,
John, hey, Todd, did they have to replace their water heater? This is Abby Daking from EPA. Did they have to replace their water heater?
No, it's still functioning. I mean, they had concerns about maintaining that old natural gas boiler, but $1,000 or $2,000 a part, which they were doing more and more frequently. But they could still be able, and they still are in a sense running that boiler. But yeah, they would love to retire it for clean buildings initiative requirements in Washington State and all that too. So
I just wonder whether they, how much more are they paying for hot water now with the system they have than what they were paying before using solely gas?
Yeah, we haven't done that economics, but we can follow up with you and share that, because that is part of our, analysis needed here at, these 20, 30 megabyte files we've collected thus far of data. So yes.
Yeah. I'm assuming it is more expensive. Obviously, that's not why they changed the solution they were using. So that's not necessarily awful, but.
Yeah.
I was quick questions. I mean, and maybe this is for John Heller, but is that recirc, the uninsulated recirc loops, is that a standard thing that you find in retrofits? I mean, that was a huge energy loss, it looked like.
Yeah, I think it depends on but in the Seattle area, pipe insulation has been in the code for quite a long time, but it has not been inspected for quite a long time, because it's not the plumbing inspector is just looking at pipes, not insulated pipes. They want to inspect the pipes before they're insulated, and there's nobody that inspects insulation. So for quite a long time, a lot of old buildings in Seattle do not have pipe insulation. And once the building is built, it's very hard to retrofit.
Interesting. And curious also, Todd, I know we're getting out of time here, but just the basement air temp didn't seem as cold as you might have thought with all those heat pumps putting cool air. So that's
it's it's big open space, and it was certainly addressed early on by Ecotop, and we put some temperature sensors in there and confirm it's relatively steady, like shown earlier, in the 60, 70 degree range. So.
Cool. Great. Well, we could keep chatting about this. Thanks for sharing that. I mean, these learnings are critical to how to move the industry forward and the costs and everything. So we'll look forward to seeing the final report on this. And yeah, thanks so much, Todd, for coming on. Really appreciate it.
Thank you very much for having me.
Well, we'll be back in the new year with more commercial heat pump water heater talk and presentations. We'll send out the slides and recording probably tomorrow. But have a great and happy holidays to everybody, and we'll see you next year. Thanks so much.
Happy holidays. Thank you.
Bye-bye. Happy New Year.
Thank you.